Welcome back to Space Repo, your portal to the cosmos. Today, we journey to a world that could have been Earth's twin, but instead became a vision of hell. Venus. The second planet from the Sun, our celestial neighbor, wrapped in a deceptively beautiful shroud of pearly white clouds. But beneath that veil lies a world gone horribly wrong. This is a cautionary tale, a story of a planet that once held the promise of life, with oceans and pleasant temperatures. So what happened? How did this once habitable world transform into a scorching, high-pressure furnace where it rains sulfuric acid? Billions of years ago, Venus and Earth were remarkably similar. Both were rocky planets, roughly the same size and mass, born from the same swirling disk of gas and dust around a young sun. Scientists believe that early Venus was a much more pleasant place than it is today. It likely had a thinner atmosphere and, most importantly, vast oceans of liquid water on its surface. Imagine a blue Venus, a world with continents and seas, not unlike our own young planet. For a time, both Earth and Venus existed within the Sun's habitable zone, the region where conditions are just right for liquid water to exist on a planet's surface. This early, temperate Venus might have even had the potential to harbor life. But the two sister planets were set on drastically different paths. The key difference was their proximity to the Sun. Venus orbits about 30% closer to the Sun than Earth does, meaning it receives nearly twice the amount of solar radiation. This extra solar energy was the trigger, the first domino to fall in a catastrophic chain reaction that would forever alter Venus's destiny. The slow, relentless increase in the Sun's luminosity over billions of years tipped the scales. As the Sun grew hotter, the surface of Venus began to warm. This increased warmth led to more water evaporating from its oceans, turning into water vapor, which is a powerful greenhouse gas. This is where the cycle begins. More water vapor in the atmosphere trapped more heat, which in turn caused the surface to get even hotter, leading to even more water evaporating from the oceans. This process is known as a moist greenhouse effect. The atmosphere became increasingly saturated with water vapor, creating a thick, insulating blanket that prevented heat from escaping back into space. The planet was slowly beginning to cook. Eventually, Venus reached a critical tipping point. The temperatures became so high that the oceans began to boil away entirely. Imagine the sheer scale of that event, entire global oceans, turning to steam and rising into the sky. The planet's atmosphere became incredibly thick and dense with water vapor. Without its oceans, Venus lost a crucial mechanism for regulating its climate and for absorbing carbon dioxide. On Earth, our oceans play a vital role in the carbon cycle. They absorb vast amounts of CO2 from the atmosphere, which eventually gets locked away in carbonate rocks on the seafloor. Without this process, the carbon on Venus had nowhere to go but into the atmosphere. Volcanic activity, which was rampant on the young planet, continuously pumped immense quantities of carbon dioxide into the air. Unlike on Earth, where this CO2 could be dissolved in oceans, on Venus, it just accumulated. The atmosphere grew thicker and thicker, dominated by this potent greenhouse gas. This led to the second, and much more extreme, phase of climate change, the runaway greenhouse effect. With an atmosphere now composed almost entirely of heat-trapping gases, the temperature skyrocketed. The water vapor that had once filled the atmosphere was eventually broken apart by intense ultraviolet radiation from the Sun. The lighter hydrogen atoms escaped into space, while the heavier oxygen atoms combined with other elements, like sulfur from volcanic eruptions, to form new compounds. One of the most terrifying results of this chemical process was the formation of sulfuric acid clouds. Instead of rain made of water, Venus developed a permanent, thick cloud deck that rains concentrated sulfuric acid. This acid rain never even reaches the surface. The ground temperature is so extreme, hot enough to melt lead, that the acid droplets evaporate hundreds of feet in the air, creating a vicious, unending cycle of toxic rain. Today, the surface of Venus is the hottest of any planet in our solar system, even hotter than Mercury, which is much closer to the Sun. The average temperature hovers around a staggering 465 degrees Celsius, or 870 degrees Fahrenheit. The atmospheric pressure on the surface is equally crushing. It's over 90 times that of Earth's at sea level. Standing on Venus would be like being nearly a kilometer deep in one of our oceans, but in a furnace. The landscape is a dry, desolate, rocky desert, perpetually shrouded in a dim, orange-hued light that filters through the thick, acidic clouds. There is no blue sky, no water, no sign of the gentle world that might have once been. Venus's story is a stark reminder of how fragile a planetary climate can be. It shows how a series of feedback loops can amplify a small initial change into a planet-wide catastrophe. While Venus's proximity to the Sun was the ultimate trigger, its fate was sealed by the runaway greenhouse effect, a concept that is highly relevant to our own climate discussions here on Earth. It highlights the critical importance of maintaining the delicate balance of gases in our own atmosphere. The story of Venus isn't just about a distant, hellish world, it's a cautionary tale written on a planetary scale. It demonstrates what happens when a planet's climate system is pushed past a point of no return. Venus is our solar system's ghost of climate change future, a permanent warning of how a beautiful, water-rich world can be transformed into an uninhabitable inferno. By studying Venus, we learn more about the processes that shape planetary atmospheres, including our own. It provides a natural laboratory for understanding greenhouse physics at their most extreme. Future missions to Venus aim to peel back its cloudy layers even further. Scientists want to understand its volcanic history, search for evidence of its ancient oceans, and pinpoint exactly when and how quickly this catastrophic transformation occurred. Was there ever life on Venus before it all went wrong? We may never know for sure, but the possibility haunts our exploration of the planet. Any evidence would likely have been obliterated by the extreme heat and pressure long ago. The tale of Venus is a dramatic and sobering one. It's the story of Earth's lost twin, a world that took a different path and ended up as a planetary furnace. It serves as a powerful reminder of the preciousness and fragility of our own blue marble in the vastness of space. Thanks for joining us on this journey to our twisted sister planet. If you found this cosmic story fascinating, be sure to subscribe to Space Repo for more deep dives into the mysteries of our universe.